All right, you bastards, strap yourselves in. Today we're going deep, deep back in time, like way further back than those overhyped dinosaurs.
Further back.
Way further. We're talking about a creature so old it makes T-Rex look like a goddamn newborn. We're talking Dickinsonia.
Dickinsonia.
And I know you're thinking, what the fuck kind of name is that? But trust me, this thing is weirder than its name.
It's true. Dickinsonia is one of the most iconic creatures from the Ediacaran period.
Ediacaran, huh?
It's so far back it'll make your head spin, a time before trilobites even existed.
Okay, so like seriously old school.
Seriously.
So paint me a picture. What the hell did this thing look like?
Imagine a ribbed, oval-shaped pancake, but like 5 feet long.
A 5-foot pancake? What the fuck?
I know, right? Scientists have been arguing for decades about what the hell it was. Was it a plant?
A plant?
An animal?
An animal.
A fungus? Or something else entirely?
Something else. All right, this is getting interesting. So let's break this down. First up, looks. What did this prehistoric pancake actually look like?
So it had bilateral symmetry, meaning it was basically the same on both sides, like a mirror image.
Okay, symmetrical pancake.
And then it had these rib-like segments running along its body.
Ribbed, huh?
Yeah, kind of like a fucked up Rorschach test.
Nice.
And the size. They've found fossils as tiny as a few millimeters and others over a meter long.
So picture one of these things washing up on the beach today.
Right. Talk about nightmare fuel.
You'd be shitting your pants thinking it's some kind of alien invasion.
Well, here's the thing. We only have imprints and casts of these things preserved in sandstone, no actual bones or tissues.
So just a ghostly silhouette.
Exactly.
Talk about leaving a lasting impression. So where did these freaky pancakes call home?
Well, they lived on the ocean floor during the Ediacaran, remember?
Right, back when shit was really weird.
Think shallow seas teeming with microbial mats, like a buffet of prehistoric gunk.
Sounds delicious.
And Dickinsonia was probably just cruising along, sucking up all that stuff.
Like a prehistoric Roomba on a bender. So who found this thing first?
It was discovered in the Flinders Ranges of South Australia back in the 1940s.
The 40s, huh?
Yeah, and get this, it was named after Ben Dickinson, the director of mines at the time.
Lucky bastard. Got a prehistoric pancake named after him. So were these things just hanging out in Australia?
Nope, they found Dickinsonia fossils all over the place, Ukraine, Russia, China. They were like the original jet setters.
Globe-trotting pancakes.
Exactly.
I heard there's a place in Australia where you can see hundreds of these things just chilling in the rocks.
Nilpena Ediacara National Park. It's like a graveyard of prehistoric pancakes.
All right, enough with the pancake talk.
Go next.
Let's cut the crap. What the fuck was this thing? Plant, animal, or something else?
That, my friend, is the million-dollar question.
Hit me with it.
Dickinsonia doesn't fit neatly into any of our modern categories.
So what it's like trying to shove a square peg into a round hole.
Exactly.
All right, lay it on me. What are the main theories in this scientific brawl?
Well, you've got Team Giant Protist. Some researchers think it might have been a massive amoeba.
A mega amoeba.
Then you've got Team Lichen, those who think it was a fungus and an alga shacking up.
Funky algae sex. Nice.
And then, of course, there's Team Animal.
Hold on. You're telling me this pancake thing could be related to us?
It's one of the possibilities. The evidence is complex and open to interpretation.
So what kind of evidence are we talking about here? What makes some people think this thing was an animal?
Well, one of the most interesting pieces of evidence is the presence of cholesterol molecules in some fossils.
Cholesterol? Like the stuff that clogs your arteries?
Yep, and it's only found in animals. Finding it in these ancient fossils was a big deal.
So they found some ancient cholesterol. Does that settle it?
Not quite.
Oh,
Some
no.
scientists are skeptical. They think it could be contamination from younger organisms.
So it's like finding a Coke can in a medieval trash pit. Doesn't mean they had vending machines back then.
Exactly. The cholesterol evidence is intriguing, but it's not conclusive.
So what else are the animal folks hanging on to?
Well, they also point to Dickinsonia's growth patterns. Remember those rib-like segments? The way they're arranged and how they increase in number as it grew suggests a level of complexity you don't see in simpler organisms.
So it wasn't just a random blob. It had some kind of structure, a plan for growth.
Exactly.
Pretty impressive for something that old. Okay, so Team Animal has its cholesterol and growth patterns. But what about the other side? What are the arguments against Dickinsonia being an animal?
The main point of contention is the lack of any obvious features, like a mouth or a gut.
So no butthole.
Apparently not.
That's kind of hard to imagine for an animal. How the hell did it eat and poop?
That's a good question, and that's what the protest camp argues. They say this lack of internal organs points to a simpler form of life.
So back to the mega amoeba idea.
Right. There are some modern protists that can get pretty damn big and complex.
All right, so we've got team animal, team protist, and then there's the lichen people, right? Fungus and algae getting it on.
The lichen hypothesis is a bit more out there, but it's interesting.
Lay it on me.
Lichens are known for surviving in tough environments, and the Ediacaran was a time of major change, so maybe Dickinsonia was an early adapter.
But wouldn't a lichen need sunlight? I mean, we're talking about the ocean floor here.
That's the main criticism of the lichen idea.
Yeah, hard to imagine a lichen thriving in the dark.
But then again, maybe these ancient lichens had some trick up their sleeve. We're still figuring this stuff out.
Man, this is getting more confusing by the minute. Cholesterol, growth patterns, missing buttholes, giant amoebas and lichens living in the dark. What the fuck are we supposed to make of all this?
That's the beauty of science, isn't it?
I guess.
It's a process of discovery, of refining our understanding as new evidence emerges.
True, but some certainty would be nice. So are we leaning towards any explanation at this point?
It's still too early to say.
You're killing me.
The evidence is there, but it's not conclusive.
So we still don't know what the fuck this thing was. That's frustrating, but also kind of exciting.
Absolutely. It just shows how much we still don't know about the history of life on Earth. And that's what makes it so fascinating.
Okay, folks, that's the end of part 1 of our deep dive into Dickinsonia. Join us next time as we dig even deeper into this prehistoric enigma.
So, last time we left off with a giant question mark hanging over Dickinsonia's head. What the hell was this thing?
The mystery continues.
And the debate is still raging, with scientists throwing theories around like frisbees at a dog park.
All right, let's dive back into this scientific shitstorm.
Uh-huh.
We talk about the cholesterol evidence, but it sounds like that's not a slam dunk. What else are the animal enthusiasts clinging to?
They're really obsessed with Dickinsonia's growth patterns. You know, those rib-like segments that make it look like a prehistoric bath mat?
Yeah, those are weird.
Well, the way those segments are arranged and how they multiply as the creature grows suggests a level of complexity that you don't see in simpler organisms.
So you're saying it wasn't just a random blob.
Exactly.
It actually had a plan, a blueprint for growth. That's pretty badass for something that was swimming around millions of years before the dinosaurs even farted.
I know, right? And that structured growth is a big point in favor of the animal hypothesis. It suggests Dickinsonia had a more organized internal structure than something like a single-celled organism.
Okay, I'm with you so far. So the animal folks have their cholesterol and their fancy growth patterns. But what about the other side? What are the arguments against Dickinsonia being an animal?
The main point of contention is the lack of any obvious features.
Like what?
Like a mouth, a gut, or any internal organs for that matter.
You're saying no butthole?
No butthole.
No stomach?
None that we found.
That's kind of hard to wrap my head around. How the hell did this thing eat and shit without those basic features?
Good question.
It's tough to imagine an animal without those essential parts.
And that's exactly what the protist camp is saying. They argue that the absence of these features points to a simpler life form, perhaps a giant single-celled organism.
So they're sticking with that mega amoeba idea?
Pretty much.
I'm trying to picture this giant blob just cruising along the ocean floor, engulfing microbes. That's a wild thought.
It is a pretty wild thought. But don't forget, some modern protists can get surprisingly large and complex, so it's not completely out of the realm of possibility.
All right, so we've got team animal and team giant amoeba. And then there's that other theory, the one about Dickinsonia being a lichen, right? Fungus and alga shacking up.
The lichen hypothesis.
That one's a bit out there, isn't it?
It is a bit of an outlier, but it does have some interesting points. Lichens are known for being incredibly tough.
Tough.
Yeah, and they can survive in some of the harshest environments on Earth. And the Ediacaran period was a time of some pretty crazy environmental shifts.
So you're saying?
So maybe Dickinsonia was an early adapter, you know? Just rocking out in those tough conditions.
Okay, but hold on a second. Don't lichens need sunlight to survive? We're talking about the ocean floor here. Not exactly a sunbathing paradise.
You're right. That is a big issue with the lichen theory. It's hard to imagine a lichen thriving on the ocean floor where sunlight is pretty much non-existent.
Yeah, I agree.
But who knows? Maybe these ancient lichens had some trick up their sleeves, some way to survive without soaking up those rays. We're still learning about this period, so anything is possible.
All right, my head is officially spinning. We got cholesterol, missing buttholes, giant amoebas, and lichens living in the dark. Where the fuck does all this leave us?
Well, that's the beauty of science, right?
Yes, yeah.
It's a process of discovery. It's about refining our understanding as new evidence emerges. And sometimes the most fascinating discoveries are the ones that leave us with more questions than answers.
True, but come on. Wouldn't it be nice to have at least a few solid answers?
I hear you.
So, which way is the wind blowing?
Right.
Are we leaning toward any particular explanation at this point?
It's still a goddamn free-for-all. The evidence is intriguing, but it's not conclusive.
Damn.
But we can say with some confidence that Dickinsonia was a pretty complex creature for its time.
Okay, but we still don't know what it was.
Right.
So the mystery continues.
It does. But think about it this way.
How?
Dickinsonia, regardless of what it was, represents a really pivotal moment in the history of life on this planet.
Okay, yeah.
This was the Ediacaran period, remember?
Right.
A time when the first multicellular organisms were starting to evolve, experimenting with different ways of being alive.
Interesting.
By studying Dickinsonia, we can actually catch a glimpse of the very origins of complex life, how it shaped the world we live in today.
So it's not just about figuring out what this weird-ass creature was. It's about understanding our own place in the evolutionary story.
Exactly. Dickinsonia is a window into a lost world, a time when life was taking those very first steps toward complexity. It's a reminder that we're all part of this incredible, interconnected web of life that goes back billions of years.
Okay, that's pretty deep, man. So Dickinsonia was a part of this evolutionary explosion, this burst of new and bizarre life forms. But what the hell happened to them? Why did they vanish? Did they get tired of the ocean and decide to go on a cosmic vacation?
That's another question that keeps paleontologists up at night.
Really?
The Ediacaran biota, which includes Dickinsonia and all its strange friends, they basically disappeared from the fossil record about 540 million years ago, right around the beginning of the Cambrian period.
Cambrian, huh?
Yeah. We have a lot of theories, but no one really knows for sure what caused their extinction.
So what are we talking about here? Giant asteroid? Climate catastrophe? Or maybe they all just decided to join a prehistoric cult and ascend to a higher dimension?
Well, a giant asteroid is unlikely in this case. But some scientists think that changes in ocean chemistry, maybe a sudden spike in oxygen levels, could have played a role. Others believe that competition from newly evolved animals with their fancy new body plans and feeding strategies might have been the culprit.
You're saying they got outcompeted and went extinct? Like the dodo?
Exactly. It's survival of the fittest, right? That's how evolution works. It's a harsh reality, but it's what drives the incredible diversity of life we see today.
I guess you're right. But hey, enough with the sentimental crap. Let's get back to the weird stuff. What are some of the more out there theories about what happened to Dickinsonia and its buddies?
Well, there's one theory that suggests they might not have actually gone extinct.
They didn't.
Nope. Some people think they might have evolved into something completely different, something we haven't recognized yet in the fossil record.
So like they got a total makeover and are hiding in plain sight.
Exactly. It's a long shot, but it's not impossible.
So you're telling me there could be descendants of Dickinsonia swimming around in the ocean right now?
It's a long shot, but yeah, it's possible.
All right, that's officially creeped me out. But it's also kind of exciting. So where do we go from here? How do we solve this mystery?
We need more research, more fossils, more data. We need to dig deeper, literally and figuratively, into the Ediacaran period. We need to analyze the evidence we have with new technologies and new perspectives. And maybe, just maybe, we'll finally crack the code of Dickinsonia and understand its place in the grand tapestry of life.
Well said. More fossils, more data, more research. That's the battle cry of science. Okay, folks, that's it for part 2 of our deep dive into Dickinsonia. We've explored the arguments for and against it being an animal, delved into its mysterious disappearance, and even contemplated the possibility that its descendants might still be lurking out there. But we're not done yet. Join us next time for the thrilling conclusion of our Dickinsonia saga. All right, you magnificent bastards, we're back for the grand finale of our Dickinsonia deep dive. We've talked about its weird-ass anatomy, argued about whether it was a plant, animal, or a goddamn alien, and pondered over its mysterious vanishing act. But what does this prehistoric pancake tell us about the bigger picture?
What's truly mind-blowing about Dickinsonia is that no matter what it was, it gives us a peek into a really crucial moment in the evolution of life on Earth.
You mean like a snapshot of the past?
Exactly. We're talking about the Ediacaran period, a time when the very first multicellular organisms were popping up, trying out different shapes and ways of living.
So These things were like the original pioneers of complex life,
Yeah.
even if they did look like someone took a shit on a bath mat.
Exactly. The Icarian biota with Dickinsonia as a VIP member represents a radical shift from the single-celled organisms that had been running the show for billions of years.
So they were like the rebels of the prehistoric world,
Yeah.
shaking things up.
You could say that. They were the forerunners of all the incredible diversity of life we see today, from jellyfish to goddamn elephants to you and me.
Holy shit, that's heavy. So we're not just talking about some weird-ass fossil here. We're talking about the roots of our own existence.
Exactly. That's what makes paleontology so goddamn compelling. It's not just digging up old bones and fossils. It's about putting together the story of life on Earth, understanding the connections that link us to all living things, past and present.
All right, so Dickinsonia was part of this evolutionary explosion, this burst of new life forms. But then, poof, they vanished. What the hell happened? Did they get wiped out by some cosmic event? Did they evolve into something else? Or did they just get bored with existing and decide to peace out?
That's another mystery that keeps paleontologists scratching their heads. The Ediacaran biota disappeared from the fossil record about 540 million years ago, right at the beginning of the Cambrian period. We've got theories, but no one knows for sure.
So what are the leading contenders in this extinction whodunit? Was it a giant asteroid, a climate catastrophe, or maybe they all joined a prehistoric cult and ascended to a higher dimension?
Well, a giant asteroid is unlikely in this case. Some scientists think changes in the ocean, like a sudden increase in oxygen, might have done them in. Others think competition from new animals with better bodies and eating habits might have driven them to extinction. Basically, they got outcompeted.
Survival of the fittest, right? So Dickinsonia and its crew got replaced by the new kids on the block. That's evolution, always changing, always adapting.
It's a harsh reality, but it's the engine behind the crazy diversity of life we see today. Even though the Ediacaran creatures are long gone, they left their mark. They were the pioneers, the ones who paved the way for all the complex life that came after.
All right, so they're gone but not forgotten. Their weird-ass forms are in the fossil record, reminding us that life has taken some pretty strange turns. But hey, let's not get all mushy. What are some of the wilder theories about what happened to Dickinsonia? Did they evolve into something totally different? Are their descendants swimming around right now, waiting to scare the shit out of some diver?
Well, one theory says they didn't actually go extinct. They just evolved into something we don't recognize in the fossil record yet. Like they went through a massive makeover.
Whoa, that's some X-Files shit right there.
Yeah.
So you're telling me there could be Dickinsonia descendants out there right now just waiting to be discovered?
It's a long shot, but it's not impossible. We're making new discoveries all the time in paleontology.
Okay, you've officially freaked me out. But it's also kind of exciting. The ocean is like a giant mystery box full of ancient secrets. So what's next in the quest to solve the mystery of Dickinsonia? What needs to be done to learn more about these crazy creatures?
We need more research, more fossils, more data. We got to keep digging, literally and figuratively, into the Ediacaran period, analyze what we have with new tech, new ways of thinking, and maybe, just maybe, we'll crack the Dickinsonia code and figure out where it fits in the story of life.
Well said. More research, more fossils, more answers. That's what science is all about. All right, folks, that wraps up our deep dive into Dickinsonia, the enigmatic pancake-shaped creature that continues to baffle and amaze us. We've explored its bizarre anatomy, its confusing classification, its mysterious disappearance, and its place in the grand scheme of evolution. And while we may never know for sure what the hell Dickinsonia really was, one thing's for certain. It's a reminder that the history of life on Earth is full of surprises, mysteries, and endless possibilities. So next time you see a bass mat, think of Dickinsonia and the crazy journey of life that led to that moment. And keep an open mind, because there's a whole lot of fucked up, amazing shit out there that we're still trying to figure out. And who knows, maybe one of you listening will be the one to finally solve the riddle of Dickinsonia. Until then, keep exploring, keep questioning, and keep diving deep into the mysteries of the universe. Peace out.